Okay, here we go. This is going to be a lesson involving some notation that I think most of you have maybe never seen before in the context of mathematics. It's not difficult, it's just new for most of you. I remember in 1963 when I was in college, yes, I am that old, seeing this symbol and wondering what the heck does that mean? I'm going to change my major from math to English. But it turns out it's not so bad. This thing that looks like a giant letter E is actually the Greek letter capital sigma, which you may have seen on fraternity t-shirts, for example, Delta Sigma Phi, that sort of thing. But in this case, sigma stands for sum as an SUM. And the way you read this notation is the sum from k equals 1 to 135 of 11k plus 15. What it means is you replace this letter K, which has to match this little k over here as well. You replace it with whatever the bottom number is. It's called the lower limit. You replace it with 1 and do the math. Well, here's what that is. And I call that first number, it's called a term. The first term is going to be a sub 1, which makes sense. It's not an exponent. It's just a subscript indicating these are different things. So a sub 1 is what you get when you replace k with 1. And of course, 11 times 1 plus 15 is 11 plus 15, which is 26. Then what do? Well, then you go from 1 to 2 and do the same thing. A sub 2 is 11 times 2 plus 15, which is 22 plus 15, which is 37. And then you replace k with 3, 4, 5, 6, all the way up to 135. However, after you've done a few of these, you don't have to do all of them because that would take a ridiculous amount of time. But we are going to need to know the value of the last term. And the last term, that's what this upper limit is all about. It's not the last term. The last term is what you get when you plug in the upper limit for the letter K in this case. So the last term is actually 11 times 135 plus 15, which turns out to be 1500. And you can verify that on your calculator. And I'm calling it a sub n. I could call it a sub 135, but I'm emphasizing that this is the last term notation that I'm going to use in this class. If you ever change your major to mathematics, it gets a little more complicated than that. However, it turns out that there is a formula for that. For what? For adding up all these numbers. So yesterday, some folks said, well, what is the goal of this? Well, the goal is to add up all of these numbers that you get by plugging in k equals 1, 2, 3, 4, etc., up to 135, and figuring out what those numbers add up to. It's called a series. And there are many, many kinds of series in mathematics. And this is a particularly interesting one because it's not that hard. And you will notice something about this. I'm sure you already have noticed 26, 37, 48, 59, 70. You probably will notice that every number is 11 more than the previous one. Oh, well, that sort of makes sense because the previous number is you're going to add 15 to 11 times 1, or 111. Then you're going to take 2 11s and add 15, and 3 11s and add 15. So it probably makes sense that every number is 11 more than the previous. And because of that, we are able to derive a formula, which I will not bore you with this morning. The sum is a sub 1 plus a sub n. What does that mean? Well, a sub 1 is simply the first number, and a sub n is the last number. And so you're going to need to know what you get when you replace k with the bottom limit, which doesn't have to be 1. It can be any whole number, really, positive or negative, but I'm going to try to keep it simple this morning, from 1 to 135. So the last number is 1500. So don't say the first number is 1, the last number is 135. No, the first number that you plug in for k is 1, but in this case, and the last number is whatever's on top. The last number you plug in for k, but the a sub 1 and a sub n are the results of the calculations using the bottom limit and the top limit. So the 26 and 1500, that's what go in here. Then you have to multiply that by the number of numbers. Now, if you counted from 1 to 135, you would mention 135 numbers, and that's what n is. It's not always the top limit, but it is when the bottom limit is 1, because from 1 to 10 is 10, and from 1 to a million is a million numbers. So you add those two together, and if you want something to think about why this might work, 26 plus 1500 divided by 2, that is the average of all these numbers. Really? Yes, it is. So you multiply that by 135, and that's going to give you the total. And here's a little clue. If you are multiplying, if you're adding, I mean, a bunch of whole numbers, you're not going to get a number 0.5 for your answer. It's just not going to happen if they're all whole numbers. Okay. But that's not always going to be the case. It turns out that I could give you the same series without using sigma notation. That's what this is called. If I just gave you the answers, 26, 37, 48, 59, 70, and so on, like this. If I said to you, I want you to add up all these numbers, 26 plus 37, etc., all the way up to 1500, I'm just going to write sum because that's a little easier. In higher math, we usually call it capital A sub n, but that's a little unnecessary here. So we can sum this series, we can add up all those numbers, provided we can determine how many terms there are, because you see, we have the 26 and the 1500. We have the first term and the last term, and we know we divide it by 2 after we multiply it by the number of terms. But when it's written like this, just strung out like that, you cannot tell how many numbers there are. And this is important. In order to use this formula above, you have to know how many numbers there are, and it only applies when these numbers have what we call a common difference. Common difference is usually denoted with the letter D. The difference between 37 and 26 is 11. Likewise, 48 minus 37 is 11. 59 minus 48 is 11. 70 minus, okay, you get the idea. So when that's the case, then and only then does this formula apply.